So changing the battery on this acquisition card on the HP 1.5 gigahertz oscilloscope, and I can tell someone's probably already changed, but we're going to change it again anyway. Because I don't know when they changed or when the last time they changed it, but first thing I guess we'll do is just measure the voltage. So we'll go right here. And you can see there the voltage, well hold on, if I can get the probe, is 3.2.35, so that's actually a good battery, but we're going to change it anyway, just so I know I got a fresh battery in there and it's not going to be a problem. But if you do that, you want to go ahead and find a point pretty much where to solder leads to. So we're going to solder one to that leg of the chip, that's going to be the positive, and then we're going to go to the ground on the negative, and we're going to feed in a 3.2 volt supply to it while we're removing the battery, so that way there's constant power, because if you go and just remove the battery, you're going to lose your calibration data. So have 3.2 volt external power fed to the chip. So now I'm going to go ahead and just desolder that battery and install a new one pretty much. So went ahead and installed the new coin cell battery onto this acquisition interface board. Hopefully none of calibration data was lost. Well, I guess I'll find out once I get this back into the oscilloscope. So went ahead and powered back up this oscilloscope and also let it warm up for a little bit. And as you can see, it held the calibration pretty much. So yep, and it's not giving you any warning, scope's not calibrated, because typically when the battery dies on these, it'll tell you right towards the top that scope's not calibrating, something about taking measurements and stuff like that, and it's not giving that warning, so likely it held everything. And we'll go and do the self-test, because one of the tests it does is it does do, of course, for the non-volatile memory. It does take a little bit. And of course, make sure you follow direction when you're doing self-test. Make sure you don't got anything plugged into the BNC connectors and so forth. Does warn you as well. Hopefully it'll be done soon. Usually it speeds up once it gets past most of the stuff. Yep, and there you go. And what I'm looking for is to make sure that the non-volatile memory passes. Yep, and it passed. See, it says non-volatile SRAM passed. So, yep, she is good. Might as well just let it run through the rest of the test. Okay. Yep, and it passed all the self-tests, as you can see, so yep, she is good. Well, she was fully working before, and I just want to make sure that I didn't screw up the calibration by replacing that battery. But so long as you keep 3.2 volts at another end of the bat, of course, don't solder the leads to where you actually desolder the battery, solder at a different point. Keep power on that board and stuff like that, you should be fine. And that's one of the batteries that people don't realize that you have to do on these oscilloscope, is pretty much they go ahead and just replace, of course, the NVRAM battery, which goes to the motherboard, the computer, but they don't ever replace the one that goes to the interface card. And that's my solder iron in the background being annoying, but they don't ever replace the battery that goes to that interface card that goes to the acquisition board on the bottom, and that's an important one because that's the one that holds the calibration for the oscilloscope. So you do also want to go ahead and check the battery on that and replace as necessary.